All right, as we continue our series on the failure files, we come to the conclusion and we go back to a familiar failure. So we've been through Macondo, Challenger, Type A, Boeing, and throughout that, we've seen a pattern of kind of missed opportunities and blind spots. I think that as we go back and take a look at this 2023 Geohazards failure, that pattern continues. It's a great opportunity as we return to an emerging threat to stop and talk about the importance of paying attention to signs that can help us see these failures before they occur. Thanks for joining us.
Giant fireball there.
Police yell for motorists to get moving as a huge wall of smoke and flame.
Homes destroyed after a huge explosion last night. It was apparently caused by a broken gas.
Oh, Chris. Today on this episode of Pipeline Things, as we continue on our failure files series, we go back to the threat that's close to me, the one that we've had guests on multiple times. In fact, we covered a failure similar to this in the last failure files that we did, and so we naturally come back to it.
Are we gonna have a guest?
No.
Is he who I think it is?
No, we don't do guests on the failure
failure
files. You know that. The failure files is just you and I. What's also cool is this is a fairly recent failure in terms of what we cover. We're going back in time to February 12th, 2023. And for the audience, we're going to be talking about a Geohazards failure.
So not that far back.
Yeah, so really, no, not that far back. Yeah, I mean, a little over 2 years ago, right?
Okay.
More recent enough where most of us can generally remember what we were probably doing in our lives at that point in time.
Yeah.
So 2 years ago, the Gulf South Index 381 pipeline, which is operated by Boardwalk, ruptures, and we have a release, but not an ignition of natural gas. I think there are a lot of points in this story that are like, I think for the audience, real eye openers in terms of lessons learned. Like in preparing for this was probably one of the easiest episodes I've ever had to check off. Oh man, this is things that operators should be aware about. Check, check, check. And really good lessons learned. I don't mean obvious things like, oh, the operator did something wrong and they should have known this, but things like, oh yeah, there's a bunch of operators that would fit this category. But point number one, we have a release in a natural gas pipeline, no ignition.
Yeah. And
the PHMSA report notes that the cost of repair was $4.8 million. That was the first thing that really surprised me. I was like, we got to $4.8 million in cleanup costs and we didn't even have a rupture. We didn't have a loss of life. That's a surprise. And the reason I chose to open with that is to put it in perspective, right? So I know for a lot of operators, when we talk about geohazards and we talk about it's a new threat, so there's always, I think, sticker shock and resistance to the idea of developing programs to address a new threat and spending additional resources. It's worthwhile just to stop before we get into the failure and say, look, $4.8 million is significantly more than I've ever seen any operator spend in their first year standing up a geohazards program.
Yeah. You can buy a lot of IMU data with that.
You could buy a lot of IMU data. You could do a lot of bending strain. You could run a lot of LiDAR with $4.8 million. So again,
on the ground.
It's worth. So, but let's go back. So this incident in February of 2023 happens on a pipeline in Jackson, Mississippi, which is second point. We are not in California. We're not on the West Coast. We're not in the Appalachians. We're not in anywhere you would typically associate with geohazards. We're in deep South. And what happens here is the Index 381 pipeline is originally an 18-inch pipeline that was built in 1939. Yeah, right. So one of our many very young pipelines in the United States.
That's circa World War II, right?
Yes, but at this particular location, the pipeline was rerouted in 1952. So what happened is U.S. Silica is the owner of the facility at the time that interacts with this pipeline, wanted to construct a detention pond in this area, and Gulf South needed to route the pipeline around. So it's real cool. So if you actually look at the map, the pipeline is straight as an arrow, except for this one place where it goes and routes around. And when it routes, they don't use 18-inch material, they use 20-inch material. So it's an 18-20 dual diameter pipeline. And the only 20-inch section is right here where they routed around this pond. and you can actually see this. So if you go, you can pull all this up in Google Earth. To the audience, I encourage you, if you pull up the PHMSA report, all this data is there, including the images. And everything in this show, I might say, we took all exclusively from the PHMSA report. It's actually a really good report. So what's interesting about this pond, Chris, is it's not a pond that's like a hole in the ground. It's a pond that they built up above the natural elevation. So they built it up with like dams and detention ponds that are above natural ground elevation. So if you were walking on the pipeline right away, you would have this big earthen dam that's like 20 or 30 feet going up from the right of way around. And what's also, again, another really fun fact that plays into this is if you go back and look at the satellite imagery of this area, we do this as part of our bending strain assessments. We're often using Google Earth satellite historical imagery. They have 26 different timestamps of this site between 1992 and 2022. So over a 30-year span, there is, I would say that's an above average number of satellite shots of this area. It really gives you a picture in an unusual way that you can kind of get a decent grasp of historically what's happening at this site. What you'll notice if the audience does that is you can see quite clearly going back to 2003 that the owner of this pond, US Silica, which is just to the north of the pipeline, was having stability issues with the dam. So you can actually see in the satellite imagery, and the PHMSA report notes this, between 2007 and 2010, you can see them doing work on the dam. Between 2017 and 2018, you can see it again. And then in 2019, you can actually see the ground cracks in the satellite imagery adjacent to this dam, right? So as you can imagine, the pipeline south of the pond, the big earthen dam is to the north, and what's happening is continually this dam is sinking, sliding into the pipeline right away. They see cracks. The dam's not high enough to retain the water behind it, so US Silica comes back and is continually repairing this dam over and over again to try and stabilize it. And in the aftermath, they basically admitted to making at least 3 attempts to stabilize the retention pond between 2020 and the time of the failure. So again, I just gave you going all the way to 2003, but even between 2020 and 2023, when this failure happened, they had been at that site at least 3 times trying to stabilize it.
Why would they make an above grade retention pond? I'm just curious about that, right? Because the water table can't be that high in Mississippi.
So I don't know the details about
That's
why.
just interesting, right? Just to think about, like, why is there an above grade retention pond?
I mean, it's a chemical, US Silica, so it could be that it's some type of a chemical thing, and maybe they have like a liner that they put above ground.
Yeah.
Point is that for some reason or another, this pipeline is built above, or this retention pond is built above natural grade,
and it's leaking.
Well, the pond's not leaking, but the retention pond is falling.
Yes, it's
right. The retaining wall, the structure, the dam, is falling. Now, what's really interesting about this, and this is where the story gets interesting, is that Gulf South was aware of the work going on. They had actually identified from aerial patrols. It's one of the few times we've seen this. The aerial patrols performed in July and September 2022 actually noted earth equipment on the right of way. Gulf South does what any prudent operator would do and sent foot patrols out to go inspect the right of way. I mean, these are all positives for the operator.
Yep, standard practice.
But unfortunately, when the foot patrols came back, they said, oh, they're not operating directly on our right of way. They're working on the dam adjacent to our right of way, which I think one of the major questions from this failure that happens is, how close does work have to be happening to the right of way in order to be a concern to the pipeline, right?
Yeah.
So,
but we've kind of talked about this a little bit before in previous episodes, right? It's like when you stand up these programs, like, what is the training effort to have boots on the ground to identify what geohazards would be, right?
And awareness, it's a challenge, right? I mean, I think, again, but I think an operator that isn't actively looking for this and sends field personnel, which is going to be a normal, typical response. The field personnel are unlikely to say, oh yeah, that dam they keep working on that's falling is falling into the right of way, and the right of way is sliding with the dam near the toe of it, right? It's unlikely. I mean, Chris, I don't think if I walked out there and I know a decent amount, I might necessarily draw that conclusion.
Yep.
You know, as an engineer, I think it would definitely take somebody with a specialty for that.
It kind of ties us back to, and this is just an open-ended question, right? It ties us back to our previous episode where it was on the Macondo one, is it's, you know, did they go out to investigate or did they go out to confirm?
And that's the question I read, right?
Yep.
Like the investigations were trying to answer, is this impacting the pipeline, right? And
Or are we confirming they're
and it's
not
out
on our
on-
right of way?
Exactly, right. And that, again, it's worthwhile. It's an important lesson in this failure that adjacent to the right of way is something we really have to be working on. So now that I've set the stage for you, you kind of know what happens, right?
Yeah.
So in 2023, what happens is this landslide that was built, or this man-made landslide, this earthen dam, has been continually falling. And as it's falling, it's pushing
It's
into the
moving the earth.
pipeline. They keep going back and restabilizing it.
Keep moving the earth.
And they keep pushing the pipeline
moving
down.
the earth.
Well, you can only push the pipeline so far out of alignment before it ruptures. And that's what happened in 2023. But there's still more information. So now that we've had the failure, I want to talk about what we gleaned after, because there are lessons after the fact as well, right? The actual failure, I think if I were to stop and ask the audience right now, I told you that we have an earthen dam that has been sliding into the right of way and it's pushing the pipeline out of the right of way.
pushing
Where
the
do you
earth.
expect the failure to happen?
Mm.
Most people are going to say probably within the portion of the pipeline that was pushed out of a way.
Yeah, but if you're in integrity, you can kind of think of it a little bit differently, right?
Maybe.
Yeah.
But I don't even I was a bit surprised.
Yeah, if there was a girth weld defect there where it was getting pressed, maybe,
sure.
because now you have like a local concentration of stress.
Yeah.
But if the girth welds are intact, then where you're pushing may not be where you're getting the most strain, right?
So in this case, the failure occurs 160 foot west of the actual landslide. Now, what's interesting, this isn't altogether different than what we saw when Marathon had its Edwardsville failure. We actually saw the failure happen near the toe, not near the greatest point of movement in the pipeline. But 160 foot away is pretty far away. And what's cool here, I noted, is that the PHMSA report actually captures the movement of the pipeline. And again, so working geohazards, people are always calling me to tell me how much pipelines move. They're like, we cut the pipeline and it moved 6 inches. It moved 8 inches. It moved 12. Look,
That's a lot.
well, to be honest, but I pretty routinely see vertical or horizontal movement of 6, 8, or 12 inches. And I tell integrity engineers that, like, look, you can't necessarily infer a whole lot because 6, 8, or 12 inches might not matter depending on how big the excavation was. But what's a surprise here is the axial separation was 14 and a half inches. So I want to put that in perspective for the audience. The two pipe ends, when they failed, pulled apart 14 and a half inches. I have never seen 14 and a half inches of axial separation. That is the largest that I've ever seen in the axial direction. It speaks to the fact that as a result of this pipeline being continually pushed out of the way, even though it was 160 foot down though, right away, it was imparting a significant amount of axial strain at this particular location. And of course, again, geohazards rarely ever produce a failure absent something else going on. They almost always follow the perfect Swiss cheese model of multiple things have to line up. We saw it in Hillsboro. We're going to see it here. In this particular location, they found it's a 20-inch pipe. They found a 26-inch long incomplete weld penetration. So think, missing root pass type thing, over 41% of the circumference. That's a pretty egregious girth weld defect by almost all standards.
Yeah.
But I also want to say it's typically what we see. Like a lot of times when there's a geohazard failure, it doesn't happen in a perfect weld. It almost always happens with a weld that has something else that looks like this. This is a vintage construction, Monday, Friday girth weld. The guy either
But it's
wanted
not
to
just
get out
vintage.
early.
Yeah, it's not just vintage. I mean, this is 1939.
No, this is the repaired section was built in 1952,
that's
right?
right,
So it's still
52.
vintage.
But even
1952.
still.
I mean, it's old,
Yeah.
but that's a lot of our pipeline infrastructure exists, particularly in the gas world, exists from that time.
Yep.
So some other fun facts that are worth talking about before we get into the lessons learned. They ran an MFLA tool in 2021.
So that means they found it, obviously.
You got it wrong. No, there are
You're kidding,
no
right?
reportable, even after
oh my
the
God.
fact, no reportable girth weld anomalies here. And audience, I'm going to tell you to hang on because that's going to be something that Chris and I are going to discuss. But for me, this was not a surprise. Like the PHMSA report specifically noted that there were no reportable features, but my first response is, yep, That does not shock me from an FLA. Now, maybe to some of our listeners out there, maybe you are surprised.
Yep.
But I want to go back. 26 inches long,
26 inches,
40% deep, at the deepest point, but no MFLA reportable feature. Second important fact, and this is probably one of the big ones, is a follow-up bending strain analysis was performed using data that was gathered in 17 and 21, right? So again, remember going back, I told you can see all the way back to 2003, this puppy was moving. US Silica admitted to doing a lot of work between 20 and 23. We now have a glimpse between 17 and 21. And the bending strain data identified a clear as day horizontal bending strain feature with a maximum bending strain of 0.207% and 3 feet of movement between the 17 and 21 data, right? Now I have to pause. So you might be thinking, hey, Rhett, 0.2% is not really that high. I know a thing or two, and 3 feet's not necessarily freak out stage. But that was between 17 and 21. This failure doesn't happen until 23. So we know we had additional movement that occurred after 21 and up to 23, right? And so again, bending strain was performed after the fact, not prior to the failure, but the bending strain analysis would have picked this up with no problem whatsoever had it been performed before, and definitely put the operator
on alert,
right? And so again, that is the data around the story. When we come back, Chris, we're going to take a break here in a moment. There's some really, I think, very clear blind spots here that a lot of operators might find themselves susceptible to. To our audience, I want to say, hang on, because I want to boil those down to really clear takeaways that you can think about in your IMP plan, or maybe how you're approaching geohazards integrity that we should all learn from. So hang on, we'll be right back. All right, welcome back as we get into the lessons learned on our failure file series dealing with the 2023 geohazard failure in the Gulf South pipeline in Jackson, Mississippi. So, and that's where I want to start.
Right. You know what I really like about the analogy of blind spot that you used? Because whenever you're checking for blind spots, a lot of times you're looking at your rearview mirrors.
Okay.
And we get to look back and learn from these guys. It's a really good analogy. So what can we learn?
Maybe, I'm teaching my son how to drive. You need to adjust your own mirrors to make sure that you can see clearly, right? Because a lot of times I get in the car after my wife's driven and the mirrors are in a totally different place. All completely off. Thank God you have a little setting now for 1 and 2.
You know what? This is unprep. I wonder if we can do this. I wonder if I typically use 3 mirrors, right? For my rear view mirrors. I wonder if we can identify 3 key takeaways out of this that we can use as mirrors. Let's do
I have
this.
4 though. Well, look.
I guess is that looking forward? I don't know.
No, but sometimes
the co-pilot maybe the co-pilot has a different advantage.
Sometimes the rear view mirrors have
that little mirror,
mirror in the corner, right? And my rear view mirror doesn't even have a rear view mirror; it's a rear view camera now, which I actually really prefer.
You're just showing
flexing a little bit for sure.
We're gonna go with the 4th, which is that little mirror on the driver's side.
The first one, look, we don't need to belabor it.
Let's go.
I said Jackson, Mississippi. To our audience out there, nobody associates Jackson, Mississippi with landslides.
Yep.
Man-made or otherwise. And this really speaks to what the Dirt Merchant and I have talked about a lot, which is geohazards don't occur in places where we often expect them, right? So if you're like, oh, deep Gulf South, don't need to worry about geohazards, you're going to miss this type of thing. So
that's probably because you're not looking for it, right? Again, you're confirming, not investigating. When you send your ILI out or you do assessment, you're confirming I don't have a problem, not,
Yep.
Am I sure I don't have a problem?
Second one for me is, again, I'm gonna quote the Dirt Merchant, is in hindsight, he says we often have the information we need to identify geohazard failures before they happen. And I actually think that's a great example. I think in this case, Gulf South had all the information, but probably not the knowledge and experience to assemble that information and recognize the warning signs that were present.
Let's be careful here. They had all the signs to what?
But where they could have taken action, like they could have identified.
Give me an example of an action, though.
So
to hire an expert to come and do an investigation, right? So I mean, because if you think about it, again, they recognized there was something going on. They sent boots out on the ground.
Got it, and that's where it stops.
Okay,
right. And that's a challenge. And I also say, again, I think a lot of operators that would have done the same thing, which is work near the right of way, isn't important. But when you talk about geohazards, near the right of way can very much impact on the right of way. So I'll give you a great example of this, Chris. We were doing a review for a bending strain feature on an operator a couple of weeks ago. Very clear horizontal pattern. He said, well, let me go bring up the LiDAR data. And I was like, let's do it. And he brings up the LiDAR data and he's like, there's nothing here. And I said, stop. And he had a huge map LiDAR feature that was to the left of the right of way and to the right of the right of way. And then the right of way was perfectly clear. And I was like, was this right of way regraded? And he's like, yeah, they did some work back when I said the regrading work made the LiDAR totally blind. And you could see like a path. It cut right through the middle of what was a very clear feature that would intersect and went through the right of way, but wasn't quote unquote on the right of way.
Yeah, I think maybe what, and again, not saying that this is what happened, this is not a fact, but again, it just goes back to, again, separate from this issue, you know, typically what are boots on the ground going to look for, right? It was third-party damage. If it's third-party damage, then I'm hyper tuned to you're on my right of way.
Right.
Whereas if I'm more tuned to I'm here for any threat, right? I'm coming to investigate what is happening on my pipeline, which often is more of that integrity approach. It's more like, oh, this is near enough. Do I have enough information to discount that a earth movement threat is happening?
You know, and Chris, that's great because what we don't know here, and the PHMSA report doesn't allude to, is what were the people that went to go investigate the right of way charged with, right?
Fair.
But I imagine that whatever task they were given probably framed up what they were going out to look for, right? And so that's just a pause point for all operators. Is that
it's just something to think about?
Yeah,
right. When you send boots out on the ground for the threat, are you being maybe too hyper focused, or they go again and back to Macondo? Are they to confirm something related to the right of way, or are they there to investigate the right of way? Yeah.
And really think about the fact that geohazards can be adjacent. There's a second important characteristic here, which we talk about, and I think operators are at various aspects, which is both bending strain and LiDAR are different. So like in this case, and I already kind of alluded to it, LiDAR might not be effective in this case.
Sure.
Because US Silica had been continually repairing the right of way. So every time LiDAR sees it, it's going to see the repairs, likely not catch the incident whenever it was in a moved state, which is going to make it very difficult for LiDAR, right? So I want to speak to a lot of the operators that are using LiDAR out there. You need to be aware that, let's say, remediation efforts can be masking the influences of geohazards on or near your right of way if somebody's repairing them. Similarly, I'm going to say bending strain can have its own blind spots when it talks about axially oriented landslides, which is not the case here. So it's a good point from a lessons learned standpoint to stop and think about, hey, a comprehensive geohazard program will often merge both of those attributes together, your surface-based assessments with...
But there can always be blind spots.
Your bending strain assessments.
Right, because if the LiDAR doesn't capture the current geotechnical environment at its worst, then now you're blind to what actually happened to the pipeline or could have happened to the pipeline. And if you're doing bending strain, maybe you're a little bit blind to
axially oriented
challenges.
But those will be picked up very well by LiDAR unless it's, again, being remediated. And we've seen that. So Chris, I gave you my two lessons.
Sure.
Do you want to give the third one? Are we just gonna make it up as we go?
No, I think one of the topics that we wanted to talk about before we got to come with some of your blind spots was you said there was an MFL inspection on this line.
Yes.
And if you heard, I was like, obviously it found it, right? But that's obviously, sometimes being a little bit facetious there in knowing that we always need to ask more questions.
Yeah.
And so some people would say, well, it's pretty easy to rationalize why MFL should have seen this. And it's a pretty gross feature, right?
For me, it was the opposite. It was pretty easy to rationalize why MFL didn't see it.
It just depends, right? Which we're getting to, right? We talk about sales jargon of ultra high resolution, right? And this is a 26-inch long feature that's 48% deep. I mean, this is a gross feature. Why would, from an orientation perspective, right, have an axial MFL with a circumferentially oriented flaw?
It's perfect.
It should have seen it, right?
But I think that again, you have to appreciate, and I think there's two things that contribute to this, Chris. Let's talk about both, because we were there. I had seen MFLA data be used to quantify or risk rank girth welds for operators where they knew they had poor issues. I had seen girth welds. Almost every operator that's running MFL has probably had girth weld related features called out. I've seen it either corrosion crossing a girth weld, or even other types of features. I've seen construction features called out. I think the challenge there is that most people might not realize it's often done on a best effort basis, right?
Yes.
Like if the tool passes over the girth weld the right way, and if the analyst is looking for it, they can probably, and I'm using all sorts of qualitative words here,
Yes.
they can probably identify it for you on a best effort basis. And a lot of times the vendors are helpful at doing that.
Yeah. And so all of those things are very anecdotal. So for as an operator, let's say you found yourself in this situation where let's go back in time, right? And say, hey, we found that there is something going on our right of way. We send a boots on the ground, confirm, yes, there's active changes there, and the integrity team gets flagged and said, hey, do we have any data that we can go look at? And let's assume, yes, there is some recent feature data that we can go and look at. And you pull up the ILI data and you're like, should I expect to see this? What I would say is it's don't just look at the data. I think it's important to call your ILI service provider, which you're looking at the data set, and ask them if their ILI specification is qualified for finding girth weld type flaws.
Yep.
Let's assume you were going to look at girth welds, right? You were going to assume that, hey, assume I didn't buckle or anything like that, that I'm looking at girth welds for failure. Ask them straight up. This is what you say. It says, is your ILI specification qualified for finding girth weld related flaws?
But let's talk about why that's such, and I want the audience to appreciate, no matter what answer you get, I want them to appreciate why it's such a challenge, right?
Yeah, we'll get there. I think what I wanted to get to first was it's because what happens is, because you said best effort basis.
Yes.
And so what you'll do is you go to the performance spec, and then there'll be POD, POI, and sizing, right? And
Yep.
they'll say, hey, if the feature's at this long, this wide, this deep, we should see it. But then it depends what type of feature. So I might get a squiggly line, I might detect it, but I won't be able to identify it, right? So I won't be able to identify a girth weld type flaw that you're interested in.
But the problem is that the girth welds, you're always going to get the squiggly lines, right? That's one of the most challenging things, right? So I want to speak to the audience. You already have I'm going to say a magnetic disruption at the girth weld, because you usually have extra material deposited in the form of a weld cap, right? So you already have a signal that's going to be, I'm going to say, disruptive from comparative to a base pipe signal adjacent to it.
Yeah. And so let's frame that, right? So we're used to people saying, it depends, and guys, qualifiers, lots of qualifiers here. It depends on the ILI system that you are looking at and considering, right? Because not every ILI system is qualified for the same type of flaws or defects.
Yes.
Not every ILI system has the same performance specification or technological basis or measurement principle. So all those qualifiers aside, it's not uncommon for people to say, hey, usually we're blind. Actually, we could even say that 2 inches on either side of a girth weld.
Right. And again, that's because of disruptions to the sensor carriers. It goes over the girth weld, all sorts of things.
Because if you have a girth weld,
pipe,
think of it as a speed bump, right? Sensor head hits it. Now you have movement. There's interference. How well can you classify that?
Absolutely.
Well, what if there's lack of penetration? Maybe there is no weld cap. Maybe the ride is smooth.
Which usually on the inside surface, but yes, I mean,
which is what I'm getting to.
Oh,
and so now the sensor head is riding on the ID. There's no weld cap for the speed bump effect.
So what you're talking about now is comparative. If we were to look at all the girth welds in the line, we're looking for outliers. We're looking for signal outliers. Got it.
Right. And so what I'm getting to, guys, is it's the whole so what of that was to say, start with understanding how the ILI system was qualified. And is there a performance spec tied to it? Because if you do that, then it sets an expectation for what you may or may not be able to get out of the data. So that then when you look at the data, you always need to try to find something to compare to. And preferably do it on a macro scale, right? Don't do it on a micro scale to, like you said earlier, hey, where would you have expected the damage to have happened? Where the bending was happening or away from it, right? So you want to try to find a like or similar type comparison before you feel like you can draw any conclusions.
I like the like or similar. And that's one area, again, where I would encourage, you said it right. I don't want people to hear you can't or shouldn't use MFLA.
Yes.
It's when you want to use it this way, you shouldn't just go in with the expectation that it can do it. But B, if you do talk to your vendor, they may be able to do some analysis that could be very helpful in potentially identifying these types of features. But it's just not your standard, hey, let's look for metal loss.
It's the idea of what we said earlier. Don't look at the ILI to confirm one of your personal assumptions. Right? You're going to look at the MFL data and have an investigation. Why do I think this could work? If it did work, what would it look like? What would I do with it if I did identify something?
So that was
point 3.
It was great, but I got to throw the fourth bonus point because I remembered. I wanted to go back to the bending strain, right? Because I wanted to talk about why it was significant. The girth weld that failed, if you look at the plots that are in the PHMSA report, it actually had no bending strain. When I say no, I mean like zip, right? Now, again, that was in 2021. It's possible that it had bending strain imparted by 2023, but given the location 160 feet away, I'm going to say that I doubt it did either. What that speaks to, though, is that, so somebody might challenge me and say, well, Rhett, how would you have used bending strain? And I wouldn't want to reiterate. When we went back and did Hillsborough, I talked about a few things. Number one, you have a horizontal feature. That's red flag number one. And number two, you have change, right? So those are red flags, again, that I always speak to operators. I speak about orientation, and stability. When you have a feature that is acting oblique or perpendicular to the pipeline, and you know it's not stable, then your flags go through the roof regardless of the magnitude of the strain, right? So had I seen a feature like this would have been what we typically call a priority 3 to an operator. I would have put them on it and been like, you need to do something immediately. Had we had the opportunity,
you need
to
to call an
this in
SME to
21.
go out there and
Exactly.
So, because and maybe you answered it, but I want to answer the question anyways. I want to ask the question to you anyways. So you said there was a 0.207 total strain, horizontal strain feature on this. And we kind of alluded to this earlier. Did it fail where traditionally you think people would have expected it failed? I mean, we kind of started talking about that a little bit. It failed 4 joints away roughly. Yeah. Right. And so when you get it, walk us through that process of saying, walk us through the process of, hey, we went to you guys or whoever you use, you called the bending strain feature. It's horizontal, roughly 0.2%. Right. You're saying it would be a point to priority 3 because of all the features that are happening. Would you have sent them to go look at the area 4 joints away or 160 feet away?
Chris, that's a fair question. I don't know. So the extent of the bending strain feature actually did not extend to cover that girth weld. So I would say that there's a decent chance that any operator may have gone out there, only looked at the portions of the pipeline that were perhaps displaced, and if they excavated, may have only even reinforced those girth welds. That's definitely a high chance. I think the key takeaway there is recognizing that the influence of geohazards on axial strain, particularly when it's oblique like this, can be large and extend definitely, obviously, 100 feet or more into the soil beyond what we might call the edges or the flanks of the landslide. And again, under normal circumstances, if that's a healthy girth weld, there's no issues. There really are not. That would not have been the place where it would have failed. But it's also being aware of when you don't have healthy girth welds, right? So that becomes another threat that operators have to be aware of, which is why, one question I often ask operators is, do you have a history of failures in girth welds in this line? So, yeah.
So to catch it, it almost sounds like you would have had to have investigated if there was a weak girth weld in this vicinity.
Man, it's a challenge.
How we do that is different.
Right? I am not going to say that in hindsight. I would have said, you need to go look at this girth weld, 3 joints away. I don't think that's fair. I don't think that's fair to go south. But it is something to be aware of when we look at them. So, all right. Hey, to our audience, I love geohazards. I think this is, again, I would really encourage you that the PHMSA report is short and to the point. It's actually a really good report with lots of lessons learned. The images are really good. So hopefully you enjoyed this episode of the Failure Files. Again, so relevant for where we are as an industry with regards to the threat of geohazards. And thanks for joining us, and we'll see you again shortly. This episode was executively produced by Sarah Etier and written by myself, Rhett Dotson. Source material can be found in the form of the PHMSA failure reports. And that's it.